right, let's go for mixed. Welcome to theme 2 of 1DV600 software technology. It's about modeling and software design. I will try to keep this in English for the international students, but you are free to answer in Swedish, put questions in Swedish if you want to. I will try to translate them on the fly if necessary. All right. I hope the stream is live and everything is working. Nice. I don't have Slack on my computer right now because it's doing the presentation. So someone in the audience here at campus will alert me if there are any interesting questions. So theme 1 was about process and planning. You have the deadline on Friday for that assignment. So we're starting this theme a little bit slowly but steadily, but I understand if you have maybe questions also from theme 1 that I will try to answer if you have them. A little bit about myself. My name is Tobias, and we have another Tobias also in the course, that's the course responsible. On Slack I'm Hobbe, and on GitHub I'm Tobias -DV -LNU. I will try to be active on Slack during these weeks at least. That's my theme. And we also have the very good tutors on Slack that are often faster than me to answer your questions. My background is from BTH, where I had my bachelor in software engineering. Then I worked at Massive Entertainment doing computer games for a while, and also at ABB Robotics doing robotic simulation software. You know, these big orange industrial robots. I was there as a consultant for almost a year. Very interesting. So basically a lot of C++ programming, a lot of real-time graphics stuff, 3D stuff. Right now I'm teaching at about 50%, a few courses throughout the year, and the other 50% I'm a student. So sometimes I'm sitting also on your side of things, since I'm doing my PhD education, and I have approximately 2 years left of that. Courses I teach here in the university is this course then, 1DV600, my little theme about modeling. You will also meet me, all of you will also meet me in 1DV607. That is more focused on modeling because it's the object-oriented analysis and design course using UML. And you will meet me again in the autumn actually. Then we will continue and go a little bit more in depth in the modeling things. I also have the course 2DV611, and it's the project course for the web programming students. So you will meet me a third time in that course when we do projects together with industry. Very interesting and nice course, I think, at least, when you get to put all your knowledge into some form of semi-realistic practical application at least. I also do some tutoring for different degrees and different papers that you will write during your final years at the university. My research is about software architecture, and I'm particularly interested in finding where the implementation does not conform to the intended architecture anymore. So when you do a software system, you often have some kind of idea of how you would like to divide it, and you kind of like draw a diagram maybe for this, and you have some boxes, and you have some arrows between these boxes that tell you that this stuff in this box can talk to stuff in this box. So I'm interested in knowing if the implementation actually conforms to this diagram or not. And if it does not, you have so-called architectural violations. And more particularly, I'm interested in finding out if we can take the implementation and put it automatically in one of these boxes, which is not so easy as you may think it is. That was a little bit short. So, what will you work with in 2 to 4 years, you think? Or what do you want to work with in 2 to 4 years? That's usually my first question. I have had this course and had the course introduction for it in past years. So this is often my starting question. So I will continue with that. I will take a look at Slack also, so I can see your replies there. So what do you guys want to work with, or what do you guys think you will work with when you get to work? You have just got your first cup of coffee at your workplace, and then you're supposed to start. What will you be doing, or what do you want to do? Any ideas? Coffee is, of course, the first thing you do, but after that, when work is starting. Anyone? Machine integration. I have no idea what that is. The usual reply I get, you're very, very silent, is that you like to press the keyboard and put down if statements and while loops and variable declarations and stuff like that. So you would like to program, do coding at work. Robotics. Yeah, that's the thing that most answer. I hope you would like to do that. Otherwise, you kind of like are in the wrong education. If you don't like programming, well, then maybe you should think a little about your choices, because you will face a lot of programming in the education. But there are other things also involved in software development, of course. So we can do implementation or do programming. Something else that you think that you will be doing at work? Planning. That's a good thing, especially if you're a lot of people. Then you kind of like need to plan what to do, who does what. Oh, I will program this part and you can program that part. That's a good thing. So we have programmers and we have planning. Anything else? Modeling. Of course, it's a good answer, especially in my theme. To be able to plan, maybe, to be able to coordinate well, especially among many people and big projects, big softwares. It's good to have some basic understanding of the different parts of this software that we're going to develop, making it easier for us to work in parallel and then join together our parts, and they will work as well as intended. So modeling. Anything else?
Researching, learning.
Yeah, researching and learning. That's a huge part actually of being a software developer. Many projects involve at least some new aspects, either a new problem to be solved or new technology to use. And learning is something that you will have to do your entire careers. Also, one of the big challenges actually in software development is that you will need to become experts not only in the technology to implement and run these systems, but also in the problem domain that they will solve. So if you work in the financial sector, you will need to learn about banking and finance and stuff like that, almost, or at least as well as your end users. So it's a very interesting work where you need to go really, really deep into other areas also, not only the programming or software technology part of things. Anything else? What themes do we have? We have the planning theme, we have the modeling theme, and we have the third theme that's about testing. Yes, testing is good, though it would be better if we did things correctly to start with and avoid testing. It's something that we will need to do at many different levels, so testing will be a big part of your day-to-day work, is my guess. Anything else? Maybe those are the big things that you think about immediately. I would actually like to add requirements to this, working with requirements in some form, that is, knowing what to do. So you basically cannot come to work and decide for yourself what you're going to do, but rather you have someone tell you that this is the functionality that we need right now, and you probably have a lot of requirements that you need to manage in some way. Before you can do planning or before you can do modeling, you need to know a little bit more about what you actually are going to do. And this course is, as you may know, a introduction to all the other stuff except programming, because that's something that you have already had. We will take a look at process and planning in theme 1. Theme 2 will be about requirements, modeling, design, and the UML, and theme 3 will be about testing. So basically we will cover most aspects of a fairly large software development project, though the project itself is maybe very, very small in this course. I hope that most of you would actually be able to implement this short little program project in a few days of programming. But that's not really the point in the course. The point is to get a feel for what is processes and planning, what is requirement, what is modeling about, what's design about, UML and testing and so forth. So while the documentation and other things around it might seem like overkill in this project, and it is, it's to introduce you to these subjects. And you will have also other courses that will go deeper into this. The modeling course, for example, you will have a testing course with Daniel also, I think, in the years to come. So some learning and some examination will be done for the theme. It will be very similar to the other themes. We have the recorded lectures. That's Jesper Andersson's recorded lecture for the theme. You have some reading instructions for the book and some extra resources to read. You have some learning materials also on my Moodle that you can check out, and also the GitHub wiki page for the assignment. We have 3+3 sessions that we will meet. And we have Slack tutoring. So these are the resources that you have to learn and use the best way possible to pass the examination. And the examination is the practical assignment that's graded from 1 to 4, where 2 is the passing grade. And you have the online test with 10 multiple choice questions, and you need 6 to pass. And maybe we should note that I've not written lectures on these times that we will meet here in the classroom, but sessions. And I hope at least that we will kind of like transition from a more lecturing kind of a session right now to a more interactive sessions towards the end. As you go deeper into the theme, you will probably have more questions to kind of like feed the sessions with, and also questions from the assignment. So that is my my goal, at least, for you to have. Ooh, I will check it. Yeah, the 3+3 sessions. We can start out with lectures, more lecture-like right now, but hopefully be more interactive as we go along. That's the idea, anyway. Though I'm happy to lecture, you already have the recorded lectures, and watching recorded lectures is not as fun anyway. So more lectures, I don't think it's needed, really. Questions so far? We had a question actually yesterday regarding GitHub, the GitHub account. That was about not being able to share the repository with more than 3 people. I think that should have been sorted out if you have the pro version of GitHub, that you should have because you're a student. So there is a link posted on Slack to sort that out if you for some reason did not get the pro version of GitHub. So let's start from the beginning. To be able to do some modeling, we need kind of like know what to model, and we need to know what our software system is about. Possibly you have already started a little bit with the requirements in your assignment, because during the assignment 1 you are supposed to, among other things, write a vision for the system, right? I think there is a vision thingamajig in the template that you have gotten. And in the vision, you are supposed to kind of like get a feel for where the project is going. What's the vision of the project? What's the end goal? Who are the users of the project? And who or what is the competition of the project? So basically, we would like to find out by using the vision if there is an opportunity at all for us to succeed in this project. You don't really have a choice in your projects, but in real life you always have the choice to cancel the project. Well, we don't understand the user needs, we don't understand the competition, and we don't really know what this system is about. Well, then you don't really have a vision, and you should not really continue with the project until you do have one. So the goal of the vision is to establish a basic understanding and a basic feasibility of the project itself. And when you have a good vision, then you can continue. And when we continue, we kind of like need to know a little bit more specified about what the behavior of the system should actually be. What should the system do? And to do this, we collect software requirements. And software requirements are simply a specification of how the product should behave or not behave in different situations to fulfill some goal of an end user. So the end user have some goals, some wants and needs, and these need to be fulfilled by our system in some way. And we specify how this should happen. What information does the user need to supply to the system, and what information will the system provide to the user? So we have requirements for the product itself, but we also can have requirements for the project. Do you have any requirements for the project in this course? Time? Absolutely. You have strict deadlines to follow. They will not change. So definitely. Do you have any other requirements on your project?
The resources, because we don't have to pick any language, it's in 2 specific languages.
Yeah, you definitely have some at least preferred languages. Some of you have been doing Java in previous courses. Some of you have been doing JavaScript. I don't know if you are limited to those choices. If you want to do something really exotic, maybe. But by some kind of design, you are kind of like limited to the implementation language also. Do you have any other project requirements? You have a shitload of project requirements. As I said before, I really hope that you would actually be able to kind of like put together this little product, this little game, in a few days of programming, if you just did the programming. It's not super big and it's not super hard if you don't add to it a lot of extra features and stuff like that. So the majority of work is not programming. The majority of work is all this other stuff that we have decided that you need to do. Oh, you need to write a vision, you need to do the planning, you need to do time estimates, you need to do this model, you need to do that, and you need to do unit testing, and you have a shitload of project requirements. More so maybe than at least the basic functionality of the product, because that's quite a simple little product. So all these project requirements that we may or may not have, either by default our company maybe works in Java or in JavaScript or some other language. Maybe our company has different templates for the project that we need to use. Maybe we have different process steps that we need to use in our project. All these can also be regarded as project requirements. Anything that kind of like affects or decides on how we need to work. Maybe we have some standards for the project that we need to fulfill. So that is one aspect of looking at the requirements. We can look at requirements from the product perspective. That is the stuff that the end users will see in some way. We can look at requirements from the project perspective, i.e. some form of limitations of technology or way to work. You can also imagine that we would like to write the code or do the design in some way that it's reusable for other projects to come, and that can also be regarded as project requirements. The other way to look at requirements is to look at functional and non-functional requirements. So for functional requirements, we have mostly product requirements and telling you what the functions of the system should be, what services will it offer, what should it do in different situations. However, the non-functional requirements are quite interesting, and that's why I've taken this picture also from the book, which is kind of like a hierarchy of requirements, non-functional requirements. So when you think about requirements, you often think about the functional product requirements, but maybe the most important requirements are the non-functional requirements, because here you have the qualities of the product, the performance, the usability, the safety, the security, the robustness, and stuff like that, that are in many ways more important than the functionality. You can have the best functionality in the world, but if you have lousy usability, no one will use this best functionality. If you have the best functionality in the world, but you have lousy security, no one will dare to use it. If you have lousy performance, no one will want to use it. We also have the project requirements in the non-functional sector, like organizational requirements, external requirements. And one aspect that I would like to stress actually is the interesting ethical and legislative requirements. There are laws that you must follow in your projects depending on what you are doing. There may be ethical stuff that you need to think about as developers. Software is becoming more and more involved in everyone's everyday of life, and you are often the final step before putting some functionality into a system. And you need to think about what impact will this functionality possibly have on people and on society. So, my next slide is about that. So, legislation, know the law. Does the system operate within the limits of the law? That's a good thing if it does. And that's often not uncomplicated. We have many laws that come. GDPR, for example. No one really knows much about that. What information can we store? What information can we not store? Should we be storing this information? Will it lead to possible problems if we do so? It might seem like a very good idea to do that from a marketing perspective, or we can sell ads, or we can know more about our users if we store this information and use it. But are we actually allowed to do so? The ethical requirements are maybe even more interesting, because here we are entering a really, really gray zone about what you as individuals actually would like to be part of and not be part of. As engineers, we, at least myself, have a tendency to kind of like use the technology for the technology's own sake more than to think about the impact it might have on society. So ethical requirements are about ensuring that the system will be acceptable to its users and to the general public. So for example, if you're installing a system at a workplace, would it be a good idea to add some form of a user monitoring system, for example, tracking who is typing on every keyboard, and by that knowing if people are actually working or not? Is it good to track what people are browsing on their internet browsers at the workplace? Could be a good idea, maybe not. So what responsibility do you as an individual developer actually have? Are questions that you will need to think about in your everyday life. For example, would you add functionality that triggers certain behavior of users in an excessive way? For example, short feedback loops have been shown to get users more involved and spend more time in systems. For example, games. Is it a good idea to add these short feedback loops? Maybe if you want people to stay in your game a lot. Is it good for the user? Maybe. Is it good for society if everyone spends their days playing games instead of doing other things? Maybe not. Would it be different if this was a casino game where you actually have real money involved? Do you think it's a good idea? Not a good idea? Would you do it because, well, the manager told me to do it? Would you add functionality that makes car emissions lower in a testing environment? Well, if you don't, maybe your car brand will not sell as many cars, and thousands and upon thousands of people will eventually be out of work. That's not a good thing, right? on the other side, it's not nice to cheat. Do you know what this is something that actually happened? The Volkswagen incident. They simply put in software in their cars that could detect that, well, we are now in a testing situation, and I will lower the horsepower to the engine so that we get a lower emission and get a better rating, environmental rating. And when driving normally, you had a lot higher emissions. Quite a big scandal. A little bit toned down in Europe, maybe, because it was a European brand of cars, and the European car industry is struggling a little bit, and it deploys thousands and upon thousands of people. So a lot of the economy rides on this. In the US, they were bashed pretty bad. A lot of money had to go into different fines and settlements of different sorts to sort this out. But at the end, it was a team of software engineers that added this functionality into the cars. So, was it easy to do you think? Do you think that they thought about this? That, well, maybe we shouldn't do it? Or did they just see, well, we have the opportunity to do this, and saw it more as a loophole than as cheating? Somewhere along the line, they kind of like must have decided that, well, we will do this, so we will add it. Another example, would you add code with bad performance that will render older devices obsolete? Maybe you have a tight deadline, you need to push functionality, you don't have the time to make it really, really optimized. Will you say, no, we should not add this functionality now, we should wait to the next release? Or do you think it's fine to add the functionality as it is, but some of the older hardware will probably not keep up? Yeah. If you're manufacturing the devices, you can see an upside. Well, people would need to buy new stuff. That's good. But is it good for society? Is it good for the end users? Probably not. This is also a real example from Apple, throttling down the battery life, I think, on some older phones, and it was also something done purposely using software, where some software engineers actually had the responsibility to add this. So, to guide us, we have different ethical frameworks actually in the discipline of engineering that we can use and should at least be aware of. Looking at the first point here, engineers shall hold paramount the safety, health and welfare of the public, and shall strive to comply with the principles of sustainable development in the performance of their professional duties. Something to think about. And there are other points here also to make that a little bit finer. But key points: general public, society, sustainable development. Some things to have in the back of your head.
There are 2 questions in Slack.
Oh, 2 questions in Slack. Does not a non-functional requirement like security force the functional requirements in the product to be secure, for example, validate inputs? Yes. I will come back to that question. I will back up a slide when we are done with this. Aren't there lawyers in the company that keep an eye on whether our software is within the law? Possibly, maybe. Depends. Depends on the company, of course. If you're working in a small company, probably not. Sometimes also people have really, really bright ideas and they're implemented quite rapidly, especially in iterative development. There is a tendency to maybe not think too much about stuff. You kind of like just add it and hope for the best, and that's not always a good thing. Looking at the ethical principles of the ACM, I don't know if you know ACM, Association of Computing Machinery, a organization for computer science stuff. Their first point here is also contribute to society and to human well-being, acknowledging that all people are stakeholders in computing. Again, society, again, looking out for human well-being and making sure that everyone is thought about when doing computer science stuff. Especially maybe important in machine learning environments, where we kind of like feed data into algorithms and we get functionality out of that. The data that we put into these algorithms need to reflect society in a good way, so that we do not build in our own biases into these algorithms that are the output of the machine learning. Very interesting and exciting area to think about. And to go with a Swedish alternative, we have Swedish engineers, and they have an honorary codex with 10 points. And again, you should feel a personal responsibility so that technology is used in a way that benefits human, environment, and society. So it's not all about if statements and for loops. Computer science and software development and software engineering is something that affects society as a whole. So a lot of responsibility is on your shoulders. And you will many times be kind of like the final checkpoint before stuff enters the system for real. And you need to take that responsibility seriously and think about things. Think about the impact it will have on your users, society, and environment. All right. Is it something that you have been thinking about when you thought, well, programming is fun? Probably not, maybe not. But you have some resources we can read more about it. And I think this is actually the first time that I've brought this up in a course like this. And I've been teaching for quite a while. But I think as more and more of society depends on software, more and more people and environment is affected by software, and decisions that are actually made by software engineers. This becomes more and more important to know about and think about. So, going back actually to the question on Slack there, many of these requirements kind of like weave together. You may have a security requirement that was mentioned in Slack that will kind of like, well, we need security, it needs to be good in these ways, and then that will generate functionality, functions in the system. For example, for it to be secure, we cannot allow SQL injection in input forms, for example. So we need to add different types of validation, filtering of input, and this will more or less be a function in our system. So the requirements are not atomic. They are not kind of like, this is the little box of the requirement. They affect each other. They form different dependencies between each other. And in any project of some form of size that's not a complete toy project, this kind of like weave of requirements will be quite complicated. And that's why we have requirements engineering. The requirements engineering are simply the activities, role, and artifacts involved in finding, documenting, maintaining, and changing the complex weave of requirements. So changing one requirement may affect other requirements, may affect requirements that we have already implemented, may affect requirements that we are planning, may contradict another requirement. So managing this is not a simple task, but rather something that requires quite an effort if done at some form of size. So do you know what activities are? Stuff you do. Do you know what roles are? The hat you put on your head. So now I'm a programmer, now I'm a tester, now I'm a requirements engineer. Do you know what artifacts are? Man-made objects in the general sense. So archaeologists, they go dig for artifacts. They go find different artifacts from a long time ago. In our domain, artifacts are often, can you give me an example of an artifact? Something that will be produced by a role in an activity. So if you have the role as programmer, the activity is implementation. What will be the output? A source code file, I hope. A file with some form of code in it. So that's the artifact. So activities have inputs, different artifacts. So for implementation, we maybe have requirement as input. We maybe have some models as input. The role is programmer, and the output is another artifact, a source code file. All right. So we should have two requirements, one for functional and one for non-functional in the security case, even if they are in symbiosis. Well, I think at least the two requirements, and maybe the more general security requirement is kind of fluffy. It's not that easy to objectively find out if it's true or false, if it's passed or not passed. So I think that writing down a security requirement would probably render a lot of more or less functional requirements regarding validation of input, regarding user accounts, regarding security of servers, processes, and documentation on how should the server be secured, what updates can be applied to the server, and so on and so forth. So it can be many requirements. It's quite easy to just write the system should be secure in the requirement specification, but that doesn't really cover a good requirement. You need to break it down into what's actually meant by that. Yes, they will be divided. So looking at the vision, maybe you often have some core features in the vision for the system that actually are very high level requirements, and these are further divided into more fine-grained requirements, and further and further and further. And where to put the limit is very much up to what kind of a project you have. For example, if you have the requirement to in your a project requirement to track time, then you may need to divide the work into quite small parts. So a function that's considered a requirement maybe will get chunked up into different pieces when planning. So it's quite a complicated weave of dependencies between all this stuff. And they affect each other, and especially these non-functional requirements. They have a tendency to affect every functional requirement. So if you say, well, we should validate all input, that will probably affect many of the functional requirements. If you say we should have some form of usability feature, that may affect many of the functional requirements. And as such, the quality requirements become quite important in the beginning of the project, because they are often very hard to change at a late stage in the project. It's often quite hard to add security before the final release. It's very hard to add usability before the final release. You can think a little bit about it as changing the programming language. That could be a project requirement. We have decided to program in Java. And suddenly, along the line, 2 weeks before release, no, we should change this to C++ instead. Probably not going to happen. So decisions that you make early in the project can have a large impact on what your choices actually are along the line. I know Jesper talks a little bit about this. He talks about local decisions and global decisions in his lectures, so you can hear a little bit more about it there. So I think it's actually a good time for a pause. If there are any questions, you can hold on to them for 15 minutes and we will start again. All right?